Hey everyone, welcome back to the channel Code with AKJ. Today is day 31 of solving LeetCode 75 challenge series. So today's problem is reverse linked list. So before moving on to the problem statement, if you are new to the channel, please make sure you hit that subscribe button and turn on the notification so that you never miss an update. Let's get started with the problem statement. So our problem statement says, given the head of a singly linked list, reverse the list and return the reversed list. So let's go through our examples. So example 1 contains 5 nodes, 1, 2, 3, 4, 5. So reversing it gives us 5, 4, 3, 2, 1. Coming to the second example, we have 2 nodes, that is 1 and 2. So we'll return 2 and 1 as an output. And coming to our final example, we have given an empty linked list as an input. So we'll return empty linked list as an output. So this would be one of our base case where we'll check if the input linked list is empty or not. So if it is empty, we'll return null. So let's understand our brute force approach and let's quickly try run with this given example. So our idea here is to store all the linked list nodes into a vector. So we'll use a temp pointer which would be pointing to head initially. So we'll run this temp until or unless it reaches the final node. We'll store all these values into a vector. And after storing all these linked list nodes into a vector, our second step here would be to start iterating over this vector from the end just to get our values in reversed order, and we'll try to create a new linked list based on these values. So since we are iterating over our vector from the end, we'll get our resultant linked list in a reversed order. So this is how our brute force approach works. So the time complexity of this approach would be O of n, as we are iterating over our linked list once and also iterating over our vector once. And coming to the space complexity, it would also be O of n, as we are using vector to store all the linked list nodes values. So let's quickly code this approach and let's submit. So here's the code for our brute force approach. So initially we'll check whether the input linked list is empty or not. So if it is empty, we'll return null. We'll take a vector of int of values which will store the linked list node values. We'll also take a temp pointer which will be initially pointing to a head pointer. We'll run a while loop until or unless temp pointer reaches null. We'll push all those linked list values nodes into our values vector and we'll move our temp pointer to the next node. So our second step here would be to reconstruct our linked list in reverse order. So initially I've taken a new head pointer which would store the last value of our vector, that is 5, and we'll also take a new pointer new temp which would be pointing to new head. So we'll start iterating over our values vector from the end, that is from values.size -2, as we have already stored the values.back value. So till it reaches 0, we'll try to run a loop. So we'll create a new node storing the values of I, and then we'll connect this particular node to new temps next. So in this way, we'll try to create a new node for every single element in our values vector, and we'll try to connect it with the help of our new temp pointer. So after finishing our for loop, we have reconstructed our linked list in reverse order. And then finally, we'll return our new head pointer which would be pointing to our reversed list. So let's quickly run this code. So again, so let's submit. As you can see, it gives successful submission, but this approach is inefficient because it uses extra space. So can we do it better? So the answer is yes. So let's quickly check out our optimal approach. So in our optimal approach, the idea here is, instead of using extra space, we reverse the pointers in the linked list that is in place using 3 pointers, that is previous, current and next. So let's understand how our optimal approach works by try running this given example. So our first step here would be to store the next pointer, that is we'll take a next pointer, we'll store the next pointer using current next. Our second step here would be to reverse the pointer, that is with the help of current next to the previous pointer. Our third step here would be to move these pointers one step ahead, that is we'll move our previous pointer to current and we'll move our current pointer to next. So these are the 3 steps we would take in our optimal approach. So with the help of these 3 pointers, we'll reverse our linked list in place. So let's quickly try run these 3 steps with this given example. So initially our previous pointer would be null and current pointer would be pointing to head. So we'll run a loop until or unless our current pointer becomes null. So we'll start with our 3 steps. So first step here would be to store our next pointer. Is next equals to current next. So the next pointer would point to the current next. So second step here would be to reverse the pointer, that is current next would be pointing to previous. So we'll remove this pointer and now it will be pointing to previous. So one is pointing to null right now. And our third step would be to move these 3 pointers one step ahead. So first we'll move our previous pointer to current and we'll move our current pointer to next. So this would be the first iteration. So let's start with our second iteration. So again we'll calculate our next pointer, that is current next. So our next pointer would be pointing to current next. So it moves to this node pointing to 3. And our second step would be to reverse the pointer, that is current next would be pointing to previous, that is whose next would be pointing to 1. And the third step would be to again move these 3 pointers one step ahead, that is previous moves to current and current moves to next. So 2 iterations are done. So coming to the third iteration, so since current is not null, we'll again move with these 3 steps. So we'll again store our next pointer. So next pointer would be pointing to the current next, so it moves to 4. Second step would be to change the links, that is reverse the pointer. So 3's next would be pointing to 2. And third step would be to move these 3 pointers one step ahead. So previous would be pointing here, current would be pointing here. So coming to the fourth iteration, we'll again calculate our next pointer, that is it will be pointing to current next. So next moves from 4 to 5. Second step would be to change the link, that is reverse the pointer. So 4's next would be pointing to 3. And third step final would be to move these pointers one step ahead. So previous moves here, current moves here. Coming to the final iteration, we'll again store our next pointer. So next pointer would be pointing to null here. And we'll change our link, that is 5's next would be pointing to 4. And our final step would be to move these pointers one step ahead. So previous would be pointing to 5, current would be pointing to null. And now we'll again check whether current is null or not. So since current is pointing to null, we'll stop our iteration and we'll finally return our previous pointer, which is pointing to the head of our reverse linked list, that is 5. In this way, with the help of 3 pointers, we are able to reverse our linked list in place without using any extra space. So the time complexity of this approach would be O of n, as we are iterating over our single linked list only once, and space complexity here would be O of 1, as we are not using any extra space. So in this way, we have optimized our approach from O of n space complexity to constant space. So let's quickly go through the code and let's submit. So here's the code for our optimal approach, where we'll use 3 pointers, that is previous, current and next. So the base case would be same, that is if the input linked list is empty, so we'll return null. So we'll use a previous pointer which would be pointing to null initially, current pointer which would be pointing to head, and next pointer which would be pointing to head. So we'll run a loop until or unless current is not null. So we'll calculate the next, that is current next. This is our first step. Second step here will be to reverse the pointer. With this line of code, you will be able to change the link of the current node to the previous. And these 2 lines are the steps where we'll try to move these pointers one step ahead. So with the help of these 3 steps, we'll be able to reverse the linked list in place. So after finishing our while loop, our previous pointer would be pointing to the head of our reverse list. So we'll return previous pointer. So let's quickly run this code. It's working. Let's submit. As you can see, it also gives a successful submission, and the time complexity here will be O of n, as we have done this in single pass, and space complexity is constant as we have not used any extra space. So the key takeaways here is, instead of storing values, we directly modified the pointers, and this solution runs in linear time and uses constant space. So let's quickly analyze our time complexity and space complexity of both the approaches. So in our brute force approach, the time complexity was O of n and space complexity was O of n as well. Whereas in optimal approach, where we have used in place reversal with the help of 3 pointers, previous, current and next, the time complexity was O of n and space complexity was O of 1. So in this way, from O of n space complexity, we have optimized to O of 1, that is constant space, without using any extra vector to store all the values, which makes the problem much more efficient for larger linked list as well. So that's it for today's problem. We have covered both the brute force and the optimal approach solutions. So if you found this explanation helpful, smash that like button, leave a comment with your thoughts, and don't forget to subscribe for more coding solutions. So I'll see you in the next one. Thank you.